Hey there, my name is Michael. This is a video about using Godot, the Godot game engine for animations. So this channel, I run a YouTube channel about. Sorry, I run a YouTube channel about. I make videos about programming and math, and oftentimes I have things in my head that I'm able to visualize, but I want to put them on the screen, and it takes a while to get there. And so I had some time off this past couple weeks, and I decided to put that time into kind of improving my ability to animate and visualize things. And in particular using Godot, which might be something of a unusual choice for a animation system. So Godot is a game engine. I'm sorry. Godot is so Godot is a game engine and a tool for making levels and whatnot. I had tried some things before in the past. So like here's a very early example of something I had wanted to show on the screen, and didn't quite work out right. But so this is I use this language called J. A lot of my videos use J, and it has some it's kind of got a weird syntax to it. So so the idea was that I would try and visualize how the parser worked, and so I created this scene in Godot, and it's not. I didn't know what I wanted to animate yet, so I set it up so that it's keyboard controlled, and so it's almost like a puppet or something where I'm controlling it with my hands, and then I can trigger little animations to cause it to grab. This is a input queue, and this is a stack, and it's grabbing tokens off the queue and putting them on the stack, and then this thing at the bottom is meant to represent the pattern matching rules. And so, in my head, I have this little machine that's doing this, and it just, I don't know. I didn't quite figure out how to, in the time I had available, I didn't quite have the animation skills or the Godot skills to make it do what I wanted to do, and I was also still kind of, figuring it out, figuring out what I actually wanted to show on the screen. Anyway, so this is an early example of what I was doing, and then just as a sneak preview of some of the things that I've done lately. This is something I just did early this morning. This is animation of a addition in a binary addition. So we've got this is the number 2 in binary. This is number 3. So these are zeros, these are ones, and then it's just going through and doing addition the way you would add normal numbers, but it's got the colored boxes to represent the digits, and then it's got the carry and whatnot. And so this is kind of like an animation I'd seen in my head. So and then just as another example of something I did recently, I made this little system here. So this is an animation of generating and then laying out in space a random Boolean expression, or the expression tree for a random Boolean expression. So this is false and the first variable x1 ANDed together, and then ANDed with another false, and then XORed with whatever's over here. So we got x, the input 0, and then we've got this is unoptimized, right? So the idea would be the next thing to show would be that as soon as you AND anything with false, then that becomes false, and then so this all becomes false, and then XORing with false does nothing, so so leaves it intact. So all this could go away, and actually you could just link it like that instead, and then all of this over here would go away. So I got the animations down, and I've got this little tool for editing graphs a little bit, but you can see it's a work in progress. It doesn't actually delete the nodes, but you can. Oh, had I not tried to delete those things, you could actually sit here and pick things up and move them around. So yeah, so this is just basically going to be like a little bit of a show and tell of like what I've learned the past couple of weeks, just experimenting with Godot, and you know, using it to do something. You know, basically building a GUI application here, a drawing tool, and some animations for visualization of algorithms and whatnot. That you know, it's meant to be a game engine. So I was surprised that it actually worked out really well. Because I guess kind of the fundamental idea is that I want you know, I want to move objects around in space on the screen, and then I want animation, but that animation needs to be, well, a perfect example is this you know, of what I'm getting at is this thing, right? So this is adding the numbers 2 and 3. Well, I don't want to animate the numbers 2 and 3 and then not be able to animate the numbers, you know, 4 and 5 or something like that. So actually, if you go to the adder node here, you can change these inputs, and then they'll change right there on the screen. And so now this is 2 and 5, and you'll see that when we run it, it adds up to 7. So if I run it now, you know, it'll do that animation for me. So the idea is that it's an animation, but configurable. You know, configurable and driven by programming. And so, you know, there are definitely tools like Manum, the guy Grant Sanderson from 3 Blue 1 Brown has a really nice tool called Manum that is like written in Python that's all about writing animations programmatically. And there are other tools out there, you know, Flash and whatnot, but or whatever Flash has become. Flash used to be you know, the big thing, but I guess it's Animator or something from Adobe now. Anyway, but I tried Godot, and I really like it. You know, it has a lot of the feel of old school Flash, where you could actually, you know, it doesn't have drawing tools, but you can import images, and you can lay things out on the screen, you know, in space, and get an idea of what you want to show, and then you can write your own drawing tools, and just tools in general. For example, these nodes, this node right here. Is a single node that generates a truth table. So it's called the truth table, I believe, is the name of the script. And it just draws a bunch of rectangles for me. So when I draw it, I know how many, you know, bits, how many bits of input there are. So how many input variables there are. So that tells you how wide it is. 2 to that number is how wide the thing is. What are the actual bits of that number? So you can go up to, this is a 32-bit input, so you can go up to 5 input variables, and it, you know, makes a long stick of bits on the screen, and then you see how big they are, and then it draws it. And then because you use this word tool, this allows it to become part of the user interface right here inside of the editor, and so you can kind of preview it live. So I'm going to get into a little bit about like how this works, and like everything that I've done. I just kind of want to like do a little bit of a show and tell here, basically. I'm definitely not an expert at Godot, but I really enjoy it so far, and I'm definitely impressed with what it can do. So I thought I would share. So just for a little bit of context, so as I said, I make programming videos. My last video, or for the past couple months, I've been working on this programming tool, or this a presentation tool in the J language, which is kind of intended for presenting, you know, my videos using J or eventually other languages. But it's all kind of like REPL based, and the idea would be like you have your script down here, and these are all the things you want to say, and then this is like the REPL interaction. So we have a nice colorful REPL in J, or you know, I've contributed that, and so now I'm I've written a script about generating the Mandelbrot set as an image, and I recorded it, and I wasn't terribly impressed with it. Everything that showed up on the screen looked, exactly the way I wanted it to look, and it was, nice and pretty, but when I watched it, it just it was too much detail, and so I wanted to put some navigation here. So the very first thing that I did here with Godot was, or recently with Godot, was I made this scene. So I took that same line of code from right here that generates this picture. And this is actually this is a rich text label, so you can use BB code, yeah. So if you look at that version, you can see all the colors. So I wrote a little J program to take my syntax highlighter and generate all this code right here. And I just pasted it into to Godot, and so right off the bat, I had all these nice, colored text. That was really easy to do. And then the idea was that this would be like a navigation bar, not navigation bar, but like a section header kind of thing. So this line would be on the screen, and then as I say, well, okay, the first part is, it's all about how this one line of code generates the Mandelbrot set. So what does this line of code do? And the first thing, well, this part is you loading the view map, the thing that draws the pictures. This part has to do with the complex plane. This part is actually doing the Mandelbrot function, the adding something and squaring the complex numbers, and doing it so many times, and then this part is all about drawing it. And okay, so that seemed like it would be a nice way to do signposts and point out what part of the code am I talking about, where does it fit in context with everything else that I've talked about so far, and that kind of thing. So it's meant to be a short video, but it just, I'm hoping that this will give some context. So I did this, and then I noticed that I had another problem, and that was that I had done some, well, as you can tell, I tend to kind of stutter a little bit when I talk. Even when it's scripted, I have a problem with this. Not stuttering, but I just, I find myself pausing in the middle of a sentence, even if I've, scripted it and memorized it or whatever. I often find myself rephrasing things or just wanting to take another take or something like that. And I wind up having to do a lot of audio of video editing. Typically I'll record an hour of video, and then it turns out to be, without even cutting a single word, just removing the pauses takes it down to 40 minutes or something like that. I have there's a really nice tool I use called Descript that does this for me. But what happened is that when it cut out all the pauses, all the work. So the point of this tool is that it in addition to showing the REPL, it actually replays the REPL, the interaction. So if I press F9 here, you can see the typing. Well, here, that's a recording of the typing of, or I guess it's not a recording. It can be a recording, but I chose to rewrite it from scratch here. But the point is that these little things are macros that play back in real time, and you can actually see I'm only pressing F9 here. And my hands are off the keyboard now, and then it's typing that. And the problem was that I put all this effort in to get the typing to look the way I wanted it to look, so that you could follow the cursor with your eyes, and then as the story is going on, and then because of the video editing, all the cursor movement got cut out. So I wanted a better video system. I wanted it. The tool I have for audio editing right now lets me take all those different takes after the fact. And what I was thinking is, what if I had a tool that allowed me to record in real time? And so Godot has, Godot comes with batteries included. It's got WebSockets. It's got audio. It's actually got a lot of stuff for media that you don't get with something out of the box like Python, right? Python is a general purpose programming language, but you got to look around to find a physics engine or to put graphics pixels on the screen, and that kind of thing. And so this comes with physics, it comes with audio, it comes with recording, it comes with video shaders, or all this kind of stuff. Just comes out of the box in Godot. So what was I saying? So I wanted to make an audio editing program. You can see. This is another thing I did. I'll talk about that just briefly in a little while. I didn't do that recently. That was a game I made a long time ago. I'm looking for... Where's my main scene? Oh, it's here. It's this one. But it's just a different... Oh, right. So I didn't load it. So main, that's why I couldn't find it. Yeah, so the first thing I did was this, which doesn't look like much here, but if I run it, it probably still doesn't look like much. And what this says at the top is hold shift to record, press space to play a sample, select with mouse, press delete to delete selection. So just right here, I can say, hello, welcome to Phenomenalix. And then, oh, you can't hear that. Let me turn up the desktop audio here. There you go. So anyway, the idea is that, here, I'll just delete something. It's an audio editor. Phenomenalix. Yeah. So I didn't, I'm just experimenting here. I didn't have a good name for this system, so it's called Phenomenalix right now. But the idea is that you can now you can go and you can for each little line of the script in here as we read this. So I say so this is like an addition table using our range as input, but the right argument is imaginary. So that's kind of a flat reading, right? I don't know what I'm not thinking about the script or whatever or in context. So it's saying like. So this is like an addition table using our range as input, but the right argument is imaginary. So that's how you generate a complex plane. Okay. Yeah. So if we visualize that with ViewMat, we see this rainbow circle. So I would say, so this is like an input table, blah blah blah, and then the next one. If we visualize it with ViewMat, we can see this. So if we visualize that with ViewMat, we can see this rainbow circle, blah, blah, blah. And so now I've got all these little, audio forms, and I can play them back one by one exactly as I want them to. And then that got me thinking, well, maybe instead of doing that live, this could just become the video editor. And so that got me thinking, well, okay, can I start, what would it take to get to the point where I could actually take these little pieces and move them around and drag them and drop them and that kind of thing. And that's kind of when I decided, hey, maybe, if I could do that, then I could do all these other things I wanted to do, right? I would be able to draw all these little pictures I wanted to draw in my videos. And so that got me thinking that I would just, that's kind of what led me towards the idea of investing some time into really learning Godot for a couple weeks. So that's what I did. I didn't know how to make drag and drop systems, so that was one of the first things I did. So one of the very first, I know how to do drag and drop, right? But every time you learn a new GUI system, you have to learn what the input events are called and all that kind of thing. So I actually loaded I went back and watched one of my very first videos, which from 10 years ago. And it was using processing for game development. And the very first thing I did was make this little, this is a recreation, but a little demo where I had these little squares and you drag them on top of each other and it would show you when they're overlapping. So, it figures out how to do collision detection. This kind of demo right here is basically enough to get you to the point where you know what the mouse is doing. You know how to take an object and drag it around inside of a scene with one being on top of another. So here, this one's on top, and now here, this one's on top. being able to draw. Even now you can see one is on top of the other, to actually find things in the scene and then whatnot. So this is like this little exercise is just enough to get you basically up to speed with like the very basics you need to do that you need for an interactive system. And so it was actually not that hard in Godot. So it turned out to be, can I make this even bigger? Yeah. So 67 lines of code. So color rectangle is just like a built-in node type. The way Godot kind of arranges everything is, you've got the, it's also a 3D engine, 2D, 3D, or you say you want a 2D scene, and then you want a overlap. You give it a, sorry, you create the scene. It has a root node, and then everything underneath it is just another node underneath it. Some of them are controls. They know how to draw themselves, and they have little rectangles. So like this is a GUI control called color rectangle, color rect. This is a label, and so you can put text in the label. And then if you zoom in, you can actually see it on the screen. Yeah. So often, like when you're in a game engine, you have this problem, which I didn't really think about at the time, but you can't. When I run it, I see all these little squares, but when I don't run it, I don't see any squares. So all you have to do, had I wanted to change that, I can say tool, and if you say tool, then it this thing is running inside of Godot. This user interface is built inside of the game engine itself. So all of these UI components are available for you to use in your own games and whatnot. So you can put a text editor in there. You can put tree controls like this. They come out of the box, and so you have access to all of this stuff. And so as a result of that, you can extend. Not only can you use the GUI system in your own games and theme it to make it look like whatever the theme of your game is, you can also extend the editor itself, which I think is really, really nice. And so I put this word tool in. So now when I go back to the 2D scene, if I say scene, reload, save scene, now I see those. I can't drag and drop them. They're not completely interactive. Like the mouse events are handled by Godot is using those mouse events, so I can't actually drag my stuff around, but I can at least see it, and I think that's a really, really, really nice tool for rapid prototyping, because you can there's a bunch of different node types that you can come with, and you can drag an image on here. There's all these different controls, or like GUI controls. There's all kinds of different things. Some of these are things that I've made, but like tabs and trees and all that stuff. And then there's all the physics, visualizations, and just lots and lots of cool stuff. Sprites, tile maps, all that kind of stuff that you would have in a game. And the point is that you can drag those things onto the screen, but when you want more, you can drag your own things onto the screen, which I thought was really, I think is really nice. And it doesn't have to just be simple tools like this. It can, things in your scene. It can be, inspectors over here, and it can be, you can even add your own little custom views up here, like extra tabs up here. Like you have full control over this thing. Not full control, but you have quite a bit of extensibility and extensive options for extending this thing. Anyway, let's see. Yeah. So, So going back to the audio thing, this told me, okay, now it's not that hard to put my. By the way, these. So for another example of that, you have full drawing control. So for like when I did this thing, this is just a white box, and I wrote all the code to render these audio clips. So I made a new type of thing, also a color rectangle, and I made it an audio clip. But if I say well, there's no audio associated with it, but if I said tool here, then it would draw that in the system, in the window, if I had audio associated with it. But this was actually pretty complicated, mostly because I didn't really understand what the format of the audio samples were. It's like a standard industry standard format, but not very well documented on the internet, as far as I could tell. But once I got past that, like the actual drawing routine is very simple. Just literally they're just samples of the amplitude of the the waveform or whatever, and so you just all I'm doing is drawing a line up and down, up and down, up and down. So like draw a line is the main thing. Of course, there's thousands of samples per second, so I'm subsampling and then draw a line. But the actual drawing part is really not that hard. I draw it as one continuous line. You could do other things. And then the same thing, overlap demo here. So the actual work was I took these color rectangles. The idea about color rectangles is or rather the dichotomy here is you got spatial is 3D stuff. Node is like non-visual things. Spatial are things in 3D. Control is GUI stuff. So like this whole window right here that I'm looking at right now is a control. And then Node 2D are things like sprites and whatnot that are inside your scene, but basically these have a rectangle associated with them, and these a rectangle, and they handle like mouse events for the GUI and whatnot, and then they have special support for that, and they have support for anchors and margins to like lay them out, whereas everything has a rectangle, but controls in particular have position and size and minimum size, and they can be laid out by containers, whereas nodes are like game objects that are they're going to be the size that they are. So sprites and things like that, and they're not part of you wouldn't want to lay them out the way you lay out a GUI. They're wandering around the screen because they're monsters or whatever. So I'm rambling a bit. I did prepare, but I didn't. I don't have a script here. So anyway, the actual code here is not that big a deal. We have input. Check if it's a mouse button. If so, you can that grabs that subnode, the mouse XY label there, and sets its text to the position of the event and so on. It wasn't that hard. I might maybe do a tutorial about this, but the point is that it's and also there'll be a link in the description to the code. It's not a pretty repository. It's not like polished at all. But you're welcome to take a look if you want. So I was able to, these are like native events that each one of these controls has. And so what's happening is I'm generating an array of boxes that I just use these control things, right? But for each one of those controls, these color rectangles. So, you can also see it at runtime. So if I run this scene, now I go here and I say remote, you can see what actually happened at runtime was that it generated all these rectangles. And so these nodes are now live in the system on the fly because of the script that ran. You can also associate scripts with your with each node. So this node has this script associated with it. So the overlap demo itself has this script associated with it. It is only a color rectangle by default, but then because I added the script, now it has all this behavior. Then in order to give those things behavior, rather than associating a script with them, you can just say, for each one of those boxes, connect its have the mouse entered event trigger a call to on mouse enter on myself. So I have one object here that causes all the coloring to happen for all the sub objects. you have a lot of flexibility in how you want to, merge, chain objects together and that kind of thing, organize your objects. So yeah, and then as far as collision detection goes, so you're doing two things. One is you're detecting whether the the mouse, the rectangle has the mouse point. So that's that's on mouse enter. So it knows, these controls do the work of tracking the mouse for you. So they would tell you that the mouse is entered, and so then I just set the subject variable to whatever I'm looking at. So whatever the mouse is over, that's the subject, and then we set it to blue. So as we go over, whichever one is the subject is blue, and then in the input events we say, well, if the subject is, basically this was enough to learn how to do dragging and dropping, and it's kind of ugly, but and I left notes in here myself so that I could eventually, talk through this in more of a tutorial. But this is just an overview for now, so I'm not going to go into it. But basically, these few lines of code is enough to trigger the drag and drop stuff, and so then as we drag, we move the child around. Actually, sorry, this is moving it in the tree, moving it to the front. But then the so if it's a mouse motion and we have a subject and the button, any button is down, then we're going to move the object around in space. So like this is the dragging part. And so these few lines of code were enough to get me started on the GUI interaction and the draggable drag and drop kind of stuff, which I later expanded into a much more complicated thing. Which I guess I'll just jump to right now. So I took that and went all the way to, wait for this to run, but we have all these little drawing tools now. So now, instead of just dragging and dropping, we've got drag and drop, but we've also got, drag on the canvas, and, do this, and then, here's a node, let's resize it, and things like that. And then, you can also, let's see, make your own little nodes or whatever, or, select them and change their colors or something. Yeah, and then there's some unfinished tools like just drawing with a pencil or whatever. And so I made this little framework, and that this was also based on stuff I had done 10 years ago for my earliest videos, some of which I never even got around to recording. But I made all this stuff, and it's just been sitting there and processing, and so I ported some of it. And I might go into that another day. But let's see. I'm kind of running out of time here. Is what I'm time boxed here. Yeah. So I wanted to. So this isn't really like. Okay. So I wanted to talk mostly about animation. So let's see. So actually, one of the even before, like months and months ago, 2 years ago maybe, I made something in here which was one of my first animations in Godot, which is this thing right here. And the idea is that well, I'll just play it. These are scene transitions for a video like this. So every time I change a topic, now I'm talking about the reload bug. Now I'm talking about question marks. I don't know. All right. So the idea is that I had something I wanted to animate, but it was parameterized. So Sand Piles was the original title that I wanted to do. So the idea is that you have this animation, and I didn't want to, it's a nice mix of visual drawing and visual drag and drop to create animations combined with programmatic animation. So the actual animation here, if we go into the scene, is here. We've got all these keyframes, and so I guess we say review and play this, and there it is. So we've got, these are objects in the scene, and then, you know, by, let's see which one. So we have a stripe here, so that stripe, we can, I think the text title exposes all of these as individual scalars, and then I'm animating those scalars. So as I change these properties, the rectangle updates, and then as I played the animation is able to take any property you want and smoothly interpolate it for you across time. And so, for example, the typing is actually the text length. So as I redraw it, all I have to do is change this number, right? And I'll make that bigger. But by changing the number, the length of the text, it just redraws it with a different amount of text drawn. So when I say, so I export that, you know, I say that this text title animation extends node. It's a tool, so I can see it in the editor, like we just saw. It has the text and it has the text length. And when I set either one of those, we call a setter function. So set get. You can put a getter as well, but so when you set it, you call set text length, which is this. And then it just modifies the appropriate strings on the on these sub objects. You can also do custom drawing, and then you just call an update function, or basically you change your behavior. You call update, and it redraws it, and then it keeps a cache of what it drew, so it has like a bitmap of what you drew, so it doesn't have to redraw redraw the image on each frame. It just keeps a bitmap of it. But here I'm just, you know, each one of these sub objects is doing that for me. This is a shutter so that I could blank out the whole screen or something in between. I think the first time I used this, I just recorded it playing one after another, and then I cut that video. Yeah, that's not ideal, but that's how I use it inside of a video. Anyway, so this was the first one I did. And you can see, you know, I'm mixing, you know, this ability to just expose a property that causes your code to run with a setter or getter, and then animating that property visually, right? So now I can see it. I can see just by dragging here, I'm executing my code, which I think is a really, really, really nice framework for animation. So that got me impressed. But then it was 2 years before I did it. Well, anything ever again. I did do one thing. So I did this. So I had made a game in Flash many years ago, and so this is I'll just play it. I'm not gonna play the whole thing. Oh, you can. I don't know if you can even see that. Yeah. Okay. So my screen says it's showing. So it's too big to see, but can I even do that? Here, I can show you the. I can show. How do I do this? All right, so I can click this camera button, and I can cause it. That should be updating the screen, and it's not. I'm not sure why it's not doing that. Oh, well, it doesn't matter. It is kind of annoying because it's a full screen window. Maybe I can't. Maybe because it's a full screen window. Anyway, well, You can't see it, but there's some text over here that's showing up in the real thing, and it shows like a little. Man, give me 1 second. I'm gonna redo this demo. So let's stop it. Project settings, and we just say full screen, right? Window over here. So we'll make it reside full screen. All right, so let me try that demo again. So this is taking that from the top here. So in this game, the reason I wanted to show this is because it does have an animation here at the start where I'm doing, this. This is a recap of the old Flash game I made, right? And then I was doing this for a game jam. So the idea is you can move around with the your WASD keys or whatever. But while it's happening, it's playing this animation. And in fact, this in the old Flash version, this was blocking, so it would block the whole screen, and you had to wait for all this garbage to happen before you could move or do anything. This is actually the final scene of the first game, right? So it's been a top-down game the whole time, and then in this suddenly you've got gravity going on, and this is like this is your first day of work. That's your boss, and anyway, you get this thing, and yeah. So the point is that I had all this animation going, and I wanted to be able to do all this while it was running. Oh, and then now you have a teleporter. This is the new game, right? I did not get far with this, but you have a teleporter now, and you can. Hey, how do you do it? Oh, that's it. It's 2 buttons. So then you're supposed to go talk to this guy and give him this thing, and he'll tell you what to do or whatever. So I didn't get very far with that. It was a 48-hour game jam, and I used that time to learn a little more about Godot. And again, I ran into the problem of animation, so which is what I wanted to talk about for real. So the idea was that in this game, I think the script is here. Yeah. So this is the animation for that opening scene. This is what I came up with. So we say, let's make it big. Can I even make it the font bigger? Yeah. So signals are things that your node emits. These are your local variables. So ready is the function that calls when you're first added to the screen. And so we create a script. And so this is code for coroutine. So we call this script thing. And the idea is that every time you run the word yield, you're able to pause, and animations are able to play, and then it can come back later. So it's a little weird. You have to be a little clever about how to manage this yield thing. So for example, sleep over here is actually calling a timer function. Where's sleep? I bet I can just click on it, right? So sleep is a function I defined that takes a number of seconds, sleep for this, and then yield wake up, sleep for that. Okay, so there's also a process. So basically I made a timer. I didn't know that Godot has a much better way for making timers, but I made this a long time ago before I learned about the right way to do it. So the right way is you just use a timer object, and then this you don't have to do all your own timing for you. But essentially, you can yield until you get a signal back from some other object, from yourself or some other object. And so that's what I do here. So, but the point was that I was able to write it like a script almost, like a screenplay. With the 2 characters' names are Teddy and Ernie, right? So Teddy's the little purple guy, and so Teddy says blah 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 in my poor head, and then we do the timing and all that stuff. And so it was actually pretty usable to use the programmatic animations, just for timing and stuff. I didn't. It seems a little cluttered to me to do the yields and the sleep fours and that kind of thing. And so I wanted it to be a little more data driven. And so I actually, in today's animation, that actually worked out pretty well. So that is binary addition here. So in the adder script, yeah. So what I wound up doing was basically make a little interpreter kind of thing for like a little, you know, was it green spunning that every application eventually has a implementation of Common Lisp, or some small implementation of Common Lisp. So anyway, this is an interpreter for a Lisp-like language, system right here, where I've got an array, and so my commands are sync to do things all in one step, in between timeouts. So here's the right way to do it. You make a timer node, and then you wait for the timeout. And then you go through the entire script. So the script is this big data structure up front. And then we go through and we interpret it, and we yield after each one. So it's actually play loops through and does one step and then yields. But if you want to do multiple things at once, you just do the steps without yielding, right? So that's what sync does. Set lets you set a node property. So call with values is like an apply. In many other languages, this would be called apply. So we call this function right here, and then we get the node, we set the property to the value. So it takes 3 arguments, which are in this array. So we pop the first argument off to figure out what the command is, and then we do something with the rest of them. So here we call this function. Travel is for the animation system, which I'll show in a minute. And then I had some trouble with that. I'm sure I just did something wrong. Like I don't really know. I think the idea is that these, well, the behavior of the animation system did not do what I expected, and so I might have some idea of like why that happened, but basically, this is moving the. Let's watch this animation again. All right, so this is the cursor. The thing that is visible is the cursor. The gold box is the cursor. But there is also a parent to the cursor, which is this thing called the carriage. And the idea is that is the following. So we have an animation for the cursor, and the animation always occurs relative to this carriage point. So the carriage is a pointed space that I can move around, and that way I only have to have one animation for this. So basically, we start out with init, and when we play init, it goes blank. And I think it's because this other thing is blank. So let's do it the right way. So we have init. And then from there we can go to adding 2 items, and then we can see the results, and then we can do the carry, and then now we descend. So we make the thing bigger, and notice that none of the bits have been being filled in. That's all done inside the inside here. So when I say set node prop, that there is a function called set bit, which is calling set node prop, right? So set bit adds some events to set the color and the line color of the of these squares right here. They start out clear. Yeah, they start out transparent like this, and so we eventually turn them into into solid forms. So actually, these are all just like rectangles, whereas the two adding things are the truth table variables or the truth table nodes that I had. So I wanted these are you just set the numbers. Oops, yeah, so there should be two input variables, and then the actual the bits are this are this input. Anyway, so these I had a canned routine because they're static, and I just wanted to change them. But then because I'm animating each one of these cells individually, and they wanted to be clear, and so this truth table thing didn't do this. So then these are separate. But they have a naming scheme, so like each bit of the result is bit R / bit 0, bit 1, bit 2, bit 3, and so on. And so it's easy to directly address one of those. And the code can easily do that just by taking a number and saying bit plus, building that name. So R, the register being the carry register or the result register. I guess carry wouldn't really be a register, but in my animation, that's what they're called. So then you have this is actually constructing that name bit 0 or bit 1 or whatever, which is right here. And so then we set that node's color and then to whatever color we want it to be. So I and O are the two colors for the true and false, or 1 and 0 bits. And then the line color is black. It starts out kind of light blue and turns black. Yeah, so I haven't done this yet, but or did I? So when we actually call set node prop set, so we just set the value right here. And what we could do instead is animate a nice transition here. So rather than just calling set, we could use a tween or whatever. I haven't gotten that far. I meant to do that. I set this object up and I never used it. But tween allows you to interpolate between colors or whatever like that. So you could say interpolate from clear to the color I want, or interpolate from clear to set the color but leave the alpha at 0, and then interpolate to full opaqueness from whatever. Yeah. So anyway, so the point is that at each step we have this little interpreter that just looks at that list and interprets it and runs the appropriate command, and then you get the animation. And it's so I'll go back to this thing. So this allows you to make a little state machine, and so you can see I have these transition animations, and then they're in the state machine, and then you just tell that state machine, you first you make the animations in your animation player, and for each one of these you just make the whatever transition you want. So this is the one that goes from having 3 items. So when you actually play it, it doesn't always update the way you expect. I think this animation tree is running live, right? So if you it's interfering with the behavior. So it's running live in the editor. You turn this off, and now when you just go to the animation player, and then you can play, and you can play backwards or whatever. Yeah, and now it'll stay. So this is the animation here, and you run this, and then now it's down. Oh, and what I was getting at is that so now this whole animation, all of these animations are using only these 2 columns, and then when I need to move the whole thing, I can pick it up and move it like that, and I do that in code. And what I had done that was confusing me was that in the animation itself, you can have the animation trigger a call to a function, but so somehow when I did this, it was looping. The animation itself was not looping, but that one call was looping over and over again, which is very strange, and it wound up shooting way off to the left. So yeah, but the idea is that now we just take these animations, we trigger each one as we see fit, but then we move the whole thing, and so we can we have very fine-grained control over when these animations run. And of course, in Godot, this is intended for like if you've got like a character in a video game and it's like he's idle, and then you press a button and he jumps or something like that. So you can see the states of the character can go into and map those out as a state machine. But it's a really nice tool for just any kind of programmatic animation. I think that's all I had to say about animation, except possibly this. So if you notice, this little background is on its own zooming in and out, and so that is running right inside the editor. I'm not doing anything for that. That is all running on the GPU, because what I have here is I have this script that I jumped right to it, but this is the shader for it. So I made the original script. You give it a random number seed and a cell size, and it just randomly generates some rectangles there that are shading, that are just like black and alpha, right? They're just shades of different degrees of transparency of black, and then you give it a main color, right? So you can change that color to whatever you want. And then I was like, well, this is still kind of static, right? So I wanted to experiment with having it pulse a little bit, just kind of subtly, so that it didn't look like you were drawing these things necessarily on a grid or whatever. And so I wrote a shader. I'd never written. I think I've written one shader before, but it's not that hard. I watched a bunch of tutorials, and I haven't been able to get it to do everything. Everything I want to do. But so this is a vertex shader. I randomly generate, or I use my code to generate this bitmap right here, and then I can apply a shader to it on the GPU. So this is running on this, this part ran on the CPU. We got this bitmap on after the call to draw was done. That's the audio system. I lost track of where here it is. The shader went, and then. I don't think that was my color, but whatever. The point is that so this is a texture. This first of all, the camera zoomed in quite a bit, and then this whole background texture is just all on one frame now. It was filling the whole screen, and then it's drawn in the GPU on a single quad. Because remember, this is a 3D engine, and so we've got like a full 3D engine in here, and I don't have any 3D content, but we could be putting boxes and any kind of 3D thing, game in here, basically any kind of 3D visualization. And so it's all hardware accelerated, OpenGL kind of stuff. It's got two different flavors of it. For whatever reason, they have different behaviors. They recommend this one for web games. Anyway, so this whole pulsing thing is, the pulsing in and out is just scaling based on time, and so it turned out to be pretty easy to do this with. And there is a so for both the scripting and the shaders, there are these things called builders. So we can make we can go into visibility. Sorry, not builders. We say material, new shader material, and then create a shader, and we say visual shader. And if we do that, now we can get, and we want this to be a, whoops, sorry. So first we got to say that spatial would be for 3D. We want a canvas item shader. So we want a fragment shader, which would fragment shaders manage the pixels on the screen, the colors. Light has to do with lighting. and vertex shaders represent the shape. So this is a vertex shader. The scaling one is a vertex shader that is scaling that one quadrilateral, that one rectangle on the GPU, and then it just knows how to render the texture on it. Whereas a fragment shader would manage the color. And so if you choose a visual shader, you get this, visual way of dragging and dropping to create things, which is kind of nice because you get you can experiment with the color. So let's see. Let's do a constant. So let's make it like red or whatever. Oops. Okay. And we can just drag that to color. Well, I guess this. So I guess the background is in the way, and then there isn't a change type. Let's make it a I don't know, a label or whatever. Yeah. Anyway, you can see it's red now. Right, and not just red. It's like each individual character is being colored red, which is probably not what you want. But like the point is that you can do that visually, right? And so we can, we can now change that with this. And you get live previews. I'm not going to mess with this anymore because it's obviously silly. But these can be very complicated, and you can also see that you can see a preview of like what the output is going to look like at any time. Assuming that your input was a solid white square, and then the output would be this solid green square. Anyway, the point of that is that you have this visual tool for creating shaders. I found this really neat for experimenting with, but then when I actually wanted to do anything, it seemed like the better thing to do was just take the text and edit the text directly. That's my preference. I don't. But this is there if you want it, and it is kind of nice if you're experimenting visually. You want the visual feedback or whatever. Okay, so what else do I want to say? Oh yeah, so basically, I just wanted to touch a little bit more on that tool keyword. So like again, like here, both for this background and for the background and for the visualization itself, by creating these parameters like the random number seed that we're going to use for it and the cell size and that kind of thing, by setting those up in the script and then using the word tool, we're able to generate all this. We have one node here, and then everything is generated by the script that runs every time I change this value. Or this value, which is kind of cool. It allows you to interact with your scripts and objects and to try different versions of them on the screen at the same time and set up test harnesses. It's just really nice to have that kind of interaction between the user interface. It's the user interface, it gives you a nice little harness for testing your behavior when you use these tools. The tool keyword. Let's see what else I want to say something else about that. So what was it? Oh, so another example of that, even simpler, was palettes, right? So Here I just have this was just a scene. So I made a script that all it does is it stores a bunch of constants, a bunch of palettes. Well, you know, the editor doesn't currently give you the little icons that you would get in like PyCharm or whatever. But even so, you might want to visualize the palettes that you're using. So all I did was I created an empty scene, and then I put the word export in front of these, and so now, and then I made an empty scene, and I dragged the script onto the root node, and now I immediately got this palette viewer. It doesn't do anything. I mean, technically I can change this, but it doesn't change the text or anything. Although it does change the actual data, and you can save it, and you can save a new palette or whatever. But it would be saved as a scene file. But just the ability to take this code, put this one word here, and now suddenly you've got an inspector here. I thought that was really neat. You actually have quite a bit of flexibility in terms of, you know, creating custom UIs for things. So like this knows how to handle an array, knows how to handle colors, but you can do even more. You can make your own little widgets and UIs for this kind of stuff. I have not gone down that path, but I'm aware that it can be done, and I think that's really neat. Another thing in terms of, so I want to go back to this game for a minute. This was another game jam I did in Flash and Flixel many years ago. Might have been in Hex or Hacks, or whatever it's called. I have not gotten this playing again. But the point is that this was made with a map editor that was made in Flash, and I could not get that running again today, you know, because nobody supports Flash anymore. It was actually made with Adobe Air, so probably I could have got it to compile somehow if I had the right SDKs and downloaded. And but the point is, I had the data for this map. It was available as a CSV file. Like the tool itself had generated in my repository from the Flash system. I had a bunch of XML, but then I also had these CSV files sitting around. And let's see, can I actually open one? Open. No. I guess it doesn't have an editor for these, but I can go in here and do I have Emacs? Oh, we'll just open one. Oh, we can open it in Excel. Okay. So machinery. Okay, so this is not pretty. But I think this is maps. Alien ship map CSV. Yeah, okay, so this is what an actual map looked like. It was oh yeah, if you zoom out, you can kind of see the structure of the thing. But you know, it's just numbers. It was just numbers for the tiles on different layers. And so what I did is I wrote a tool that would allow me to parse that CSV file and even edit those CSV files by hand. Where is it? So CSV tile map, alien ship machinery. So each layer of the oh, I see. Yeah, so the first one I did was this. So you give it a CSV file, and then you tell it which one of these tile maps you want to update, and then I think you had to press this button because I don't know how to put a button in there yet. But you press that button, or you press this checkbox, and it reloads that. So it immediately turns that checkbox off, but it also kind of shook the display here a minute. And what was happening is it's actually reading. It's actually reading that CSV file and updating the scene in the editor. So you have the ability to put like macros in the editor, but also eventually build a user interface for it. You can again, I didn't know how to do it. I still don't know how to I haven't tried actually doing this, but you can build like, things like panels like this to pop up that have whatever user interface you want in this thing, including, your own drawing tools, your own custom animations. They can be in 3D, they can be in 2D, whatever you want. You can build all of these things. So anything you can do with Godot itself, you can do to extend the editor, which I think is really, really nice from a user interface point of view. And so this was just parsing that CSV file and populating this. So I didn't have to basically, so I could iteratively, edit that script, press the button, and see if what imported worked and whatnot. So it worked out really well for me. I didn't get much further than that, but for this particular project, maybe someday I'll go back and finish porting the game over. But as far as getting my maps in and placing the objects, that worked out really well. So the second one there is the second option. So those are the tile maps, and then the actual objects are not tiles, but they're just that's the other kind of file you see here. It says like this is the X coordinate, Y coordinate, and then what kind of object is there. So it's a sparse representation. And so for those, I just for that script, these are all using the same script, or I guess these two are. That's the mob importer script, and so then that was you give it the path inside your directory to where the CSV file is, and then I use this little check button, so when I set the go the go button, it triggers this thing and then unsets the underlying variable. But then it runs this script, and again, there's probably better ways to do that. But I just haven't learned how to build panels over here. Yeah, I've been talking for an hour now, so I think that's all I'm going to say. I obviously I've just kind of barely scratched the surface of what Godot is and can do. I mean, I haven't even talked about making games all that much. It is a game engine, but in terms of like just building presentations and stuff, I really think it's a really nice tool. So I highly recommend checking it out. And I don't know. I don't know if I don't really want to become a tutorial channel, but I am happy to share my experience if people are interested. So there may be more Godot content coming on this channel. Yeah. So in particular about where is it? This one. Right. So this one in particular. Not the layout, but so I probably will be talking about this actual data structure and about the tree layout routines algorithm at some point in the future. The algorithm for laying out this tree is kind of naive and silly. It's the naive one I came up with, and I was thinking I would study up on the more advanced ones and do a little talk about laying out graphs on the plane. But this is still very much a prototype code. I mean, it still doesn't have a real name. It's called Finarbnix. You can't see it on the screen, but it's it's very much a work in progress that I intend to continue to develop as I try to continue to put more of my the ideas I see in my head, or the pictures I see in my head, on the screen. So expect to see more about this in the future. Anyway, that's it. So I'm gonna sign off there. So thank you for watching, and